The design shows the boards needed for bracing the back of some set scenery. Will 75 feet of wood be enough for all of the bracing? So we see the scenery over here, right? And it's 7 feet wide in this rectangle, and then there's a rectangle that's like a side, which is 4 feet wide. Let A represent the length of the diagonal for the smaller square, and B represent the length of the diagonal for the larger square. Because we need wood for the frames, right? And we want to brace the back of the set, and so we want to put diagonally. Okay, so yeah, and then we're going to determine the length of the diagonals by using our Pythagorean theorem, right? So yeah, we know that by the Pythagorean theorem, right, we have a side A, side B. If this is a right angle, your hypotenuse is going to be A squared plus B squared, right? So the square of your hypotenuse is going to be the sides squared, the sum of the sides squared. So using that, we can figure out the diagonal, the length of the diagonal for each one. And then we know, yeah, so yeah, we're going to take the square root, because yeah, we're going to assume that these are squares over here, and so we're going to be able to set up equations using the Pythagorean theorem. 4 squared plus 4 squared should equal to A squared, and then 7 squared plus 7 squared would be equal to B squared, and then we figure out that the diagonal length would be 4 root 2 and 7 root 2, and so we need 3 edges that are 4 feet, 1, 2, so this one 1, 2, and 3. Then we have 4 edges that are 7 feet, like 1, 2, 3, 4. And then we have 2 diagonals for the 7 feet, and then 7 root 2. And then we have 2 diagonals for 4 root 2. And then we're just going to add them all together. And so when we write the equation, we have 3 times 4 plus 4 times 7 plus 2 times 4 root 2 plus 2 times 7 root 2, and that's equal to 40 plus 22 root 2. So you can add the like terms together, the like radicals together, and then add the constants, and this is a simplified expression. And if you want to figure out the exact solution, this is the exact solution. If you want to figure out the decimals, right, you can use a calculator. So evaluating it, it'll be about 71.1. And so 75 feet that we have should be enough for bracing the set scenery. So yeah, that's the answer. Let's look at try number 4. How can you rewrite each expression in a simpler form? So let's combine like radicals and rewrite these into simpler form. Simplify. Pause the video, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? So in order to be able to add the like radicals, you have to simplify your radicals, your terms first. So your first step is to factor out. So look at part A. You're going to factor out 2,000. Okay, so first factor out 2,000 into the smallest bases, smallest factors, until you cannot. So 5 times 25, 5. So 2,000 really, cube root 2,000 is really 2 to the power 1, 2, 3, 4, which is cube plus 1, right? And then times 5 to the power of cube, right? And so this one, you can rewrite this into 2 times 5 cube root 2. Does that make sense? And so that is going to be 10 cube root 2. And then we have plus square root 2, so you can't add these two. And then let's simplify that as well. 128, factor it out, factor it out. Then you have 1, 2, 3, 4, 5, 6, 7. So 2 to the power of 7th root 3 would be the same as cube root of 128. And so rewriting this as cube root of 2 cubed times 2 cubed times 2, right? You can cancel these out and get 2 times 2, so that's 4 cube root 2. And so ultimately you'll be able to add the like radicals. 10 minus 4 would be 6 cube root 2, and then root 2 is just root 2. You can't combine anything. So this would be a simpler form. So if you simplify part A, you will get 6 cube root 2 plus root 2. Let's look at part B. Same thing. You're going to rewrite these roots into a simpler form for each one, and then you will add the like radicals. So 20, factor it out, and you have 2 squared times 5. So 2 root 5 is root 20, right? Because 2 square root of 2 square would just be 2. And then 600, factor it out. 75, and then 15, and then 3, 5. So yeah, 2 cube, and then times 3 times 5 square, and this is a square root, so if you have a square, that's out. So 2 times 5, which is 10, so minus 10 root 2 times 3, 6. Okay, and then the last one, you're going to factor out 125. Yeah, I think we did that somewhere. Let's do it again. 125, 5 times 25, 5 times 5. So that is going, yeah, over here. We already factored out. So this is really 5 root 5. And then you can add these like radicals, and then that's just going to be by itself. So 2 minus 5 would just be negative 3, right? So negative 3 root 5 minus 10 root 6 would be the simpler form. All right, so check your answers, see if you got it right. If you did, good job. Let's go to example 5. Multiply binomial radical expressions. What is the reduced radical form of each product? So let's look at part A. Cube root of 7 times parentheses 2 minus cube root of 49. We're going to use the distributive property and multiply them out. And then you'll see that 7 times 49 is going to be 7 cube. So 343, that's 7 cube. And that cube and the cube root would cancel each other out and get 7, right? And same thing for this one. If you multiply by 2, it's just 2 cube root 7. And so, yeah, that's it. So simplify each term, and the product would be written as the simplified version. Let's look at part B. You need to use the binomial, what is it? the FOIL method to multiply the binomials, right? And so multiply 2x times 2x, 2x times negative root 3, negative root 3 times 2x, and then negative root 3 times negative root 3. Negative root 3 times negative root 3 is positive root 9, which is just positive 3. And so you can simplify that. And then negative 2x root 3 minus 2x root 3, they're like radicals, so you can add them, and the x term is also part of the like terms, right? So then you can add the 2's together and then get 4, negative 4x root 3. And so the product finally would be in this form. So simplify your product as you go if you can. Otherwise, just simplify it after you've multiplied everything. So let's look at try number 5, A and B. So multiply the binomials and multiply using distributive property. Pause the video, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? Let's look at part A. So 5A, you're going to multiply x minus root 10 times x plus root 10. So using the FOIL method, you have x squared minus x root 10, right? Wait, plus root 10, and then minus x root 10, and then minus root 10 times root 10. So it's x squared, and then this plus and minus cancel each other out, and then this one is just negative 10. So you just get x squared minus 10. Let's look at part B, 5B. Root 6 times 5 plus root 3. You're going to distribute it out and get 5 root 6 plus root 3 times 6, which is 18. And then you have 5 root 6 plus, so that's really 2 times 3, right? 3 times 2 times 3. So you have 3 squared, so you can pull that out and get root 2. Unfortunately, we don't have like radicals, so then that's just going to be it. 5 root 6 plus 3 root 2. Okay, check your answer, see if you got it right. If you did, good job. Let's move on to example 6, rationalize a binomial denominator. How can you rewrite 1 over 2 plus root 5 without a radical in the denominator? So we want to rationalize a binomial denominator by rationalizing the denominator using conjugates. So remember the conjugates we looked at it for complex numbers, right? The same thing for radicals work. So 2 plus root 5, we don't want radicals in the denominator. So we have to rationalize the denominator. Rationalize means we shouldn't have roots, or we shouldn't have, we need to simplify the denominator. We shouldn't have complex numbers and all that. So multiply the conjugate of 2 plus root 5, which is 2 minus root 5, right? And in order to keep the expression the same, you have to multiply the same thing for numerator, so that you're just basically multiplying by 1 and you're keeping it the same, right? And then you will get rid of the radical, because eventually you will have a square for this one, and so you're going to be able to cancel out that term. So then we have 4, and then we add and minus the middle terms, right? And so that's gone. And then we square this and you get a negative, so minus 5. So 4 minus 5 is just negative 1, and that really makes it easier for us, because we can just multiply negative to each of them and get positive root 5 and minus 2. So this could be rewritten as root 5 minus 2 when you rationalize the denominator. So let's practice. Try number 6, A and B. Pause the video, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? So what's the reduced radical form? This is called a reduced radical form. You are reducing the radicals, especially in the denominator. So you're going to rationalize the denominator and simplify as much as you can, if you can. And that's going to be the reduced radical form. So let's start with this. What's the conjugate of the denominator? 2 plus root 3. So you're going to multiply 2 plus root 3 over 2 plus root 3. And then you have 2 square and then plus and minus 2 root 3. So that's canceled out. You have negative 3 because root 3 times root 3 is 3. And then you have 5 times 2, 10. And then you have 5 times plus 5 root 3 minus 2 root 2, and then minus root 6. And then you can simplify. 4 minus 3 is just 1. So your denominator is gone. Everything divided by 1 is just itself, right? And then we have no like radicals in the numerator. So you just write 10 plus 5 root 3 minus 2 root 2 minus root 6. Okay, good. Let's look at part B. Same thing, you're going to multiply the conjugate, 1 plus root x. 1 plus root x. Okay, and then you have 1 times 1, 1 square is just 1, and then 1 times root x, and then 1 times negative root x, they're going to cancel each other out, and then negative root x times root x is just going to be negative x, right? And then this one, you use the distributive property to distribute negative 4x out into the binomial. You have negative 4x minus 4x root x. Yeah, and I think that's it. You can't really simplify any further unless you multiply this by 1 plus x again, and then you have squares and all that. But you can just leave it like this. You already have a reduced radical form. All right, so check your answers and see if you got it right. If you did, good job. That was the last example of this lesson. So let's summarize our lesson 5-2, properties of radicals. So let's look at the properties again and summarize. Product property of radicals says that when you have factors in the same radical symbol, your radicand could be written as factors, and then you can separate them. You can separately write them into two different radicals with the factors, right? And then quotient property of radicals basically says that it's the same thing when you have the factors, when you have a fraction, a rational number as your radicand, you can rewrite them as separate roots with the same quotient. And then you can rationalize the denominator using the conjugate of the denominator for the radicals. So these are examples for algebra, and these are examples for numbers. And then this is an example of using properties of radicals. So for example, if you have this, you can factor them out and then use the product property of radicals to rewrite this into a multiplication sentence, and then you can bring them out. You can cancel the roots and then rewrite them as a reduced radical form. And this one, you can multiply the conjugate of the denominator to get rid of the radical in the denominator. All right, so that was lesson 5-2. We'll continue with the next lesson in the next video.